Hi, uh, a very good day to all of you. Welcome you to this video, which is the second video of Module 3 of electrochemical machining and chemical machining of non-traditional machining subject as per the VTU syllabus. In the last class, in the last video, I discussed about the electrochemical machining or the basic working principle of electrochemical machining. So in this current video or in this video I'm going to continue with the basic elements or the five basic elements which are the parts or basic elements of five basic elements of ECM. So let us go with the five basic elements. I have listed these five modules in my last video. Five basic elements of electrochemical machining. First one is about cathode tool. Second one is the anode workpiece, power supply, electrolyte filtration and delivery system, tool feed system and working tank. This tool is always connected as a cathode in the electrochemical machining. That is what we study and that is what I have discussed even in my last video. Uh, Cathode is a tool is connected always as a cathode polarity in the electric circuit, and workpiece is connected as a anode in the ECM. The second important element is power supply. The power supply which is connected to in this electric circuit of ECM is of very high current density, which is a DC power source. The third one is of electrolyte filtration system. The electrolyte is need to be filtered before it is being sent to the machining zone. And next one is about delivery system. Once it is being filtered, once the electrolyte is pumped, it is to be filtered, and then the pressure of the electrolyte is to be monitored, and it has to be regulated to the desired pressure, and then it has to be sent to the machining zone through the hole which is present in the tool itself or in the other way. The third one is about the tool feed system, how the tool is being fed into the machining zone. Last fifth important basic element of this ECM is working tank. Because in this ECM process, the workpiece is fixed on a fixture, and the whole setup is mounted on a insulating base. This insulating base is kept in a container. The container contains this whole setup along with the electrolyte in which this workpiece or tool are being dipped. So let us go with the first one, the tool and the workpiece. In electrochemical machining, generally aluminum, brass, bronze, copper, stainless steels, they are generally used as tools. Important thing is it should be a good conductor of electricity. That is nothing but here the electric source is connected in the electric circuit, and workpiece or a tool both are acting as a one of the electrodes in the process. So when it is to be acting as electrode, obviously it should be a good conductor for electricity. That's why only a good conductor of electricity workpieces can be used, or a good conductor tools can be used. So there is no restriction for the workpiece. That is except the characteristic like whether it is a good conductor of electricity or not. based only that is the criteria for the selection of the workpiece, or else there is no question of whether it is a very hard material or a soft material. All those things are not very important criteria here, because the material is being removed by the removal of or separation of metal ions due to the electrolysis phenomena. So no, even if it is a hard material or a soft material, whether because of the electrical electrolysis process, whether the metal ions are able to be dissoluted into the electrolyte solution or not, that is the only criteria. That's why there is no restriction for the workpiece based on its metal characteristics, material mechanical characteristics, material mechanical characteristics. Further, the removal rate is proportional to the atomic weight and inverse of the valency of the material, because based on that the metal ions are being discharged from the workpiece. That's why these are the two important basic elements which need to be considered, and this metal removal rate is mainly dependent on these two parameters. One is atomic weight and the inverse, and another one is the valency of the material. And the relationship exists as the material removal rate is proportional to the atomic weight and inverse to the valency of the material. The next one is power supply. The process needs low voltage, uh, 2 to 20 volts, and high current. A step down transformer with a rectifier is used to maintain a constant DC output at a preset voltage. The voltage you can see here, it is of very low voltage, which is of 2 to 20 volts, whereas when we check with the current, it is a very high current. Generally we speak about 1 amps, 2 amps, 5 amps, 10 amps maximum of, whereas here we can see it is of 800 amps per centimeter square. So high current is being used here. Further, a step-down transformer with a rectifier is used to maintain a constant DC output at a preset voltage. Here, a constant DC output is expected. DC source is connected here to obtain a constant output. That is the major reason why we are connecting the DC voltage and DC power source here. Further, a constant DC output at a preset voltage is being achieved because when the current or a power source which is provided to the electrodes are of constant or a steady state, then only we can achieve a better quality machining, or else the intermittent machining will cause the so much waviness kind of surfaces, or a variation in the material removal rate, and also and many such kind of undesired machining characteristics. Further, a proper care has to be taken to avoid sparking that may damage both the tool and the workpiece. A proper care is to be taken to avoid sparking which may cause tool and the workpiece. Here the sparking is mainly occurring because when the tool becomes contact with the workpiece, because during the machining in the initial state both are at a very larger distance, or they are kept much apart with respect to each other. But as the machining is progressing, or the process is progressing, the tool is brought slowly towards the workpiece, or the tool is advancing towards the workpiece, so that the material is removed from the or the metal ions from the workpiece surface is being removed or dissoluted into the electrolyte based on the shape of the tool. While moving the tool towards or advancing the tool towards the workpiece, a care has to be taken such a way that the tool at any instant the tool is not making contact with the workpiece or in a very small distance, which may cause sparking or arcing, which may cause damage to the both tool as well as the workpiece. or it is not only causing the damages to the tool and the workpiece, the sparking may also cause a serious damage to the whole setup also sometimes, or the power source or the whole electric circuit. That's why a proper care is very necessary to avoid the sparking. The third important element in the electrochemical machining is electrolyte filtration. In electrochemical machining, the electrolyte performs some of the following functions. First one is about completing the electric circuit between the tool and the workpiece. When the tool and the workpiece are connected in a circuit as a two electrodes, thus both are kept apart until unless the electrolyte and both are dipped in electrolyte solution, the electric circuit will not get completed. Though both are connected to the power source, they are kept apart, so obviously it is not it is not becoming a complete electric circuit. Whereas when both are dipped in electrolyte solution, then the whole electric circuit will become completed. And further it acts as a conductor to carry the current. Whenever we speak about the carrying a current in a conductor is nothing but movement of electrons from one point to the other point. That is what we can signify it as a transport of current or a movement of current. So carrying current is nothing but moving the electrons from one location to the other location. So this is possible here because only when the electrodes are dipped in an electrolyte solution, and these electrolytes will cause the action of carrying the current from one electrode to the other electrode. Further, it removes the products of electrochemical reaction from the gap between the tool and the workpiece interface. During the process, as we have discussed till now, or even in my last video, that when the workpiece is being machined here with the help of ECM operation, then the metal ions get dissoluted and get dissoluted into the electrolyte solution. So when if we keep those metal ions in the electrolyte solution, there are chances like these metal ions will may further reduce, and due to the reduction the metal ions may get deposit over the tool. So it is highly necessary that these metal ions need to be flushed away from the machining zone. So that's why the electrolyte is fed into the is delivered onto the machining zone at a high velocity, so that it can flush away those metal ions from the machining zone and can uh, uh, and can avoid any chances of or probability of getting a plated over the other electrode or nothing but the tool. Further, another important point is about heat generated from the machining. Obviously there is a chemical reaction, then we can say that there is a liberation of heat energy also. And the second thing is the metal ions are getting dissoluted from the its parent metal surface, and it is dissolving into the electrolyte. So obviously these are also some chemical reactions, and yeah, since everything is connected in electric circuit, that also will cause the movement of electrons, will cause the generation of heat energy. This liberation of heat energy need to be taken away from the machining zone, or else it will catalyze further, or it may cause the detrimental effect on the machining characteristics. May the machining may not go in a very controlled way. So these all things need to be avoided or prevented during the machining. That's why the heat generation need to be completely eliminated, or generated heat energy need to be taken away from this machining zone. That major function is being carried out by the electrolyte. Since electrolyte is a solution which is generally a salt solution, which takes away the generated heat energy from the machining zone. The types of electrolytes which are being used are sodium chloride, potassium chloride, sodium nitrate, and sodium chlorates. These are some of the inorganic salts. Generally, they are used as electrolytes. Even based on the requirement of the machining, material removal rate and surface roughness characteristics, the type, concentration is being selected. Coming to the types of electrolytes, generally the sodium chloride is best. It is the most cheapest and possesses a very good conductivity of very good electrical conductivity, but it is highly corrosive and hence it cannot be used on a TC or pure titanium and molybdenum materials. So in that case, generally the sodium nitrate is used as an alternative to, because it is highly popular due to its less corrosive in nature. It is popular due to its less corrosive in nature, but at the same time it does not produce a very good surface finish as that of sodium chloride solution. Hence, and at the same time, it is expensive that compared to the, it is relatively expensive compared to the sodium chloride. That's why it is preferred for machining aluminum and copper when it is only an alternate solution. Then in many cases, a mixture of sodium chloride and sodium nitrates are used to machine the titanium alloys. In this table, we can have a glance of different types of salts and their application over the workpiece material. Let me go with the first row here. The sodium chloride. Sodium chloride or potassium chloride or sodium nitrates, they are specially meant for machining, electrochemical machining of steels, iron based alloys, steel alloys with nickel and cobalt base. So Fe-rich alloys are generally mainly Fe-rich alloys like iron-based alloys are generally machined with the sodium chloride or potassium chloride or sodium nitrate electrolytes. Whereas aluminium and its alloys, copper and its alloys mainly preferred with the sodium hydroxide, potassium chloride or sodium chloride. Chloride and sodium nitrate, again it is used to machine a gray cast iron, which is again a Fe-rich alloy. The last about the titanium alloys. Sodium chloride or potassium chloride with a mixture which is mixed with sodium nitrate, they are preferred over for machining for titanium alloys. This is a summary of different types of electrolytes for a unique workpiece materials, like with the corresponding workpiece materials. Coming to the desirable characteristics of electrolytes. First one, high electrical conductivity and easy ionization. Uh, Electrolytes need to be highly conductive to the highly conductive to the electrical energy, and once the metal ions get dissolved, or it should prone towards causing the metal ions to get separated from its parent surface. That is why the easy ionization, like this salt, when it is that a electrolyte solution, it should have a rich amount of Na minus and Cl Na plus and Cl minus ions. So it should be easily able to get ions in its solution, and also should be more prone towards causing the high electrical conductivity, which may cause more prone towards the metal ions get separated from its parent's metal surface. Second one, about the low viscosity for easy flow. When the when it is about a viscosity, it clearly indicates that the easiness with which the fluids are flowing. That is clearly indicated by its viscosity. When let me take an example of an oil and compare it with the water. uh, Obviously the oils are a high viscous compared to the water, so because of which the motion of the oil, the movement of the oil is resisted, whereas the water will flow very much easily. That's why the in the if I want to inject something, if I want to make it to flow easily through to the some location, then it is easy for me to flow the water into that location compared to the water. That's why highly viscous fluids are not preferred here, or high concentration fluids are not preferred here, whereas a low viscosity, the electrolyte need to possess a very low viscosity so that it can easily be pumped to the machining zone. And a high specific heat, when it possesses a high specific heat, then it indicates that it has the more capability to absorb more amount of heat energy which is generated in the machining zone. The fourth important is about chemical stability. When they are chemically stable, then only they are best suited for the electrochemical machining process. To be chemically neutral, or it should not get disintegrate during the reaction. Another next is about the resistance to formation of passivating film on the workpiece. Let me take an example of aluminum. When it is subjected to the atmospheric environment, then obviously it forms a thin layer of aluminum oxide on its surface, so that further chemical reaction is completely prevented. So that is such kind of a film, we call it as a passivating film, which is need to be avoided, which the formation of such films need to be avoided, because if such film is formed over the surface of either a tool or on the workpiece, then further chemical reaction will not occur, or further for machining progress will not be achieved. And electrolyte should not be corrosive. You should not cause any kind of corrosion on the workpiece. And it should be non-toxic. That is, the fumes of this electrolyte should not, or the smell, odor, this should not be harmful to the operator, because he is very close during the machining. And it should be inexpensive, as in a lot of electrolyte is required during the machining. That's why inexpensive kind of electrolytes are preferred. They should be easily available electrolyte solutions are preferred over the other electrolytes. The salt solutions with water forming a large proportion satisfy many of the above conditions, and hence they are generally being used. Filters. Filters are placed in the system to clean the contaminated electrolyte, so that a fresh flow of electrolyte to the machining area takes place. Filters are placed especially to clean the contaminated electrolyte. This contamination will get occur into the electrolyte, because these electrolytes are being recycled. Once it is being machined, the metal ions will form a compounds and get precipitate in the electrolyte itself. So these suspensions or precipitations need to be cleaned away from the electrolyte solution. So that's why this kind of contamination should be filtered out, or which may be caused during the machining process, or it may be even when we are using fresh electrolytes. Any kind of other unwanted or undesired kind of suspensions need to be taken away from the electrolyte solution, and a fresh flow of electrolyte should be provided to the machining zone. That these are all about the basic elements of the uh, electrochemical machining. And about the tooling system, ECM tooling. The tool used in the ECM process is approximately the mirror image of the shape to be machined on the workpiece. In the last video, when I was discussing about the shape of the tool, I mentioned very clearly that the shape of the tool should be in such a way that it is exactly the mirror image of the workpiece, or a shape of the work which is to be obtained on a workpiece. So in detail about this ECM, in detail about the ECM tooling, I will discuss it in detail in my next video. So please watch my next video. In my next video, I will discuss in detail about the ECM tooling techniques. Uh, so thank you. Thanks for watching this video. Uh, Please subscribe for the up-to-dates of on this module 3. If you have any doubts, you can mail it to my email ID. Uh, Obviously, I have used different resources like textbooks and internet resources for preparing this teaching material. Through this video, I acknowledge all such sources which has helped me to prepare this teaching material, which is also very helpful to many of the students who are following this video. And as a disclaimer, I hereby declare that I don't claim any kind of novelty or originality in my in this video as my own, uh, and it is completely acknowledged to all different sources which has been borrowed to prepare this teaching material. So thank you all to such sources, as well as thank you for you to watching this video. Thank you. Bye. Have a nice day.